All right, let's take a look at the periodic table of the elements and its terminology. First thing we want to look at are groups or families of elements. Those are the vertical columns that you see on the periodic table. Periods, we're going to examine nonmetals, metals, metalloids, which are three broad categories of elements. And then specifically, we're going to want to learn which groups are the alkali metals, the alkaline earth metals, chalcogens, halogens, noble gases, and what we call the transition elements. And here we are. So the first thing you want to wrap your minds around are what we call groups. These are also called families. So vertical columns are called either groups or families of elements. Now, here is one of the cool things about groups of elements. You're going to find out later when we get into quantum mechanics that groups of elements, the vertical columns that you find on the periodic table, they have similar physical and chemical properties. That is, their chemical behavior, sometimes their appearance, is similar. So groups of elements, that is, elements that are in the same family, have similar properties. And then we have periods. And as we go across the periodic table looking at periods, this is lithium, beryllium, boron, carbon, nitrogen. The atomic number, that is the number of protons in the nucleus, goes up by 1 as you go across a period. So these are called periods. All right. In pink on this particular periodic table, and I've shown you this before in a previous video, everything on, well, let's be a little bit more precise, going down that line. The green guys are the metalloids. These pink guys over here, these are all metals. On this periodic table, if it's pink, it's a metal. Now, this is the only periodic table I have where you have pink metals, but there you go. And then we have the non-metals, and on this particular periodic table, you'll need to reference this without noting color, because the periodic tables you'll normally use will not have colored designations. But all these blue guys over here, these are what we call non-metals. So these are non-metals. On this periodic table, if it's blue, it's a non-metal. And these guys right down here in green that are inside these very rough red lines I've drawn here, these are called metalloids. And they're very special elements because they share properties with both the non-metals and the metals. How special are they? Well, think about silicon. Silicon is in all the electronic devices that you have. It is the primary basis for computer technology. That's the material we currently use in computer chips. So all of these elements are very special in their properties. You can find uses for each and every one. And so very special elements. These are the metalloids. Those are the green guys. So know the general categories. All right. Let's look at some specific categories that you need to know. Over here, we have the group 1 elements, and that's excluding hydrogen. Hydrogen is a group 1 element, but it is not what we call an alkali metal. They start with lithium, goes down to francium. You won't really have to worry about francium because it exists in such small amounts, it's radioactive. But lithium, sodium, potassium, rubidium, cesium, you need to know that each and every one of these is an alkali metal. Now, it's in group 1, so I'm going to go ahead and give you some information about that. Now, I've said before that metals have this propensity to lose electrons. That is, they do what we call oxidize. That's what we mean by losing electrons. And that means they become cations. So if I take lithium metal and I oxidize it, it oxidizes to a +1 and it spits off an electron. And guess what sodium, potassium, rubidium, and cesium do? They're all alkali metals. So if I go down here to the bottom, cesium, it oxidizes to a cesium +1 cation and spits off an electron. And these guys are so reactive in group 1, and by the way, they're in group 1 and they all oxidize to a +1 cation, lithium, sodium, potassium, rubidium, cesium. Guess what? They're so reactive that we don't find any of them in nature as metals. We find them all as +1 cations in salt. So you would have something like, let's say, lithium chloride. That's actually what we call a salt. We're going to learn about that in just a bit. So lithium, sodium, potassium, rubidium, cesium, the alkali metals, they don't exist as atoms. They only exist in their +1 cation state in what we call salts or ionic compounds. All right, that's probably a little bit much, but let's keep on going anyway. Guess what we got for the group 2 metals? These are called the alkaline earth metals down here. They are all in the same group or family. That's beryllium, magnesium, calcium, strontium, barium, radium. They're metals. They like to lose electrons. And so if I have calcium, calcium really wants to lose how many electrons? Well, it's in group 2. That's your clue. They all oxidize to a +2 state, so you're going to get calcium 2+ plus 2 electrons. Let's go over here to the other side of the periodic table. Now, up here, we're talking about nonmetals. And nonmetals, unlike the metals, nonmetals, they like to accept electrons. All right? Now, this particular group, group 6, or 6A, depending on the version of the periodic table. You can also designate it as group 16. We call these the chalcogens, and you need to know the names of these groups. Now, nonmetals like to gain electrons. Oxygen, and by the way, over here we have what we call the noble gases. Most of you are at least a little familiar with the noble gases. And the noble gases are very stable. They don't like to react. Guess what all the elements really want to be like? They all want to be like the cool kids, the noble gases. So oxygen will gain 2 electrons to become an oxide 2- anion. And all you have to do is count over. You've got oxygen and then fluorine and neon. There's 2 spaces over to get to be just like its nearest noble gas neighbor. And that's going to be true for oxygen, sulfur, selenium. So just pay attention to the nonmetals at this point. Oxygens, sulfur, and selenium. And tellurium has properties of both metals and nonmetals, so we're just going to kind of leave that one alone. These guys all want to gain 2 electrons. And let's go one more over. These are called the halogens. Fluorine, chlorine, bromine, iodine, and they would like to gain 1 electron to be just like their nearest noble gas neighbor. And so, for instance, if I've got the halogen chlorine, it would like to gain 1 electron to become a -1 chloride anion. Okay, if you remember that from an earlier lecture. These are the noble gases. Most of you are familiar with the noble gases, and they're very stable. They're the cool guys on the periodic table. They really don't react. Okay, now in the middle, we've got what we call the transition metals. They're metals. They like to give up electrons, but we don't know. We can't specify that they only give up 1, 2, 3, 4 electrons. Each one of them, because of the way the electrons are organized around the nucleus, will have different oxidation states. So unlike the alkali metals giving up 1 electron, the alkaline earth metals giving up 2 electrons, the transition metals, they might be +1, they might be +2, +3, +4, depends on the metal and the environment that they're in. Down here we have the rare earth metals. These are some very pricey metals on the market and hard to find. They're called the rare earth metals.